Sauce here. This is a video lesson on linearization. We have simple equations. A line is a relatively simple relation, mathematical relation. We have more complicated curves. An equation that curves is a more complicated mathematical relation. And of course, our functions and our curves can get very complicated. In order to study complicated curves and functions, we have techniques to use lines as models for the more complicated behavior. We do that because what we know about lines and the math that we can do with lines is very simple. So if we can reduce a complex situation and model it by a line, then we can study it or study more complicated situations more thoroughly. So complicated functions need to be able to be linearized. And what do we mean by that? Well, let's take a look at a very sharp curve. In this case, the function y is equal to 10 to the x. This is an exponential function which is very curved, especially at this place where it changes quite rapidly. And when we zoom in on that curving place, and we keep zooming in, we can see that the curve's sharpness evens out and gets straighter and straighter. This idea of zooming in on a curve to see its behavior at very zoomed in points is linearization. The zooming in and focusing on tight locations linearizes the curve. We can visually see that the curve becomes like a line. I'm going to add an equation of a line to compare our exponential equation. Y is equal to the natural log of 10 times x plus 1. I chose this equation. It is a line whose slope is what's multiplying x, which is the natural log of 10. But I've chose this equation because they intersect at the point 0, 1. And if I zoom in on that point of intersection, I can see that the purple exponential curve gets gradually and gradually more close to the linear black line. And in fact, I can turn the line off, zoom in on that location until it looks perfectly straight, and then turn the black line on, and it almost completely covers it, and will if I zoom in even more. This is a demonstration of the line being an extremely close approximation of the exponential curve, and the closer we zoom in, the more the line resembles the curve. The curve is being linearized. Why is this an important idea? Because where we can linearize a function, then we can use the mathematics of lines to tell us about the more complicated curving function. But we can't linearize every location. For example, the equation y is equal to the magnitude of x, or y is equal to the square root of x, is this familiar graph. And if we zoom in on any point on this graph, it will continue to be a line unless we zoom in at the origin. And no matter how far we zoom in, the graph is never going to resemble a line. It has two distinct pieces which are linear, but they continue to come to this point. This point here is not curved in nature. We end up calling a feature of a graph that has a feature like this a corner or a cusp. Corners and cusps are not linearizable, so they're problematic when we try to use the mathematics of lines and linearization to teach us or inform us about the more complicated curve.